Hello everybody, and thank you very much for joining today's Arbor Day. My name is Derek Eames, I work as an arboriculturalist, and a bit ago I was privileged to be at a Sapflow measure and psychrometry workshop with Andrew Hirons from ISCO, and along with a representative from ICT International who actually manufacture Sapflow measure equipment. And we found this is a very interesting and fascinating principle that enables us to actually find out what's going on inside the actual vascular system of the tree. So a bit ago I decided to actually invest in one of these instruments, and there we are. That's what it looks like, and we have three microprobes that is inserted into the tree. And this actually enables us to actually measure the amount of sap flow or the amount of moisture uptake coming up from the roots of the tree, which provides some fascinatingly interesting results. So it enables us to actually see what's going on inside the tree, totally apart from any visual tree assessment. So how it works is you've got in the centre, you've got a heat pulse probe, and that is picked up by the actual sap flow. Moisture picks up the actual amount of moisture going up, and the thermistors in the outer probes picks up the heat exchange, and this enables us to record what we call raw data. So on the screen there, sorry it's a little bit blurred, but the actual software picks up the actual change in temperature, and this is then analysed, and the raw data is actually converted into real-time data to provide us with a measure of the actual amount of moisture that's actually been taken up by the tree. So there's a few things we have to take into account. We have the anatomy of the tree. It might be a ring porous or a diffuse porous tree. And in this particular instance, on the right there, we've got what seems to be a ring porous tree. You've got a dysfunctional heartwood, and then you've got an annulus of functional sapwood. So now we need to calculate or estimate that area, and then we have to take into account the depth of phloem and bark as well in order to get an accurate measure. So most diffuse porous trees, functional xylem occupies about 70 to 95% of the stem cross section, and in ring porous trees only about 21% of the xylem is functional. However, it's not quite as simple as that. So what I find in diffuse porous trees, such as maples and so on, is that sap flow density peaks at about 4 centimetres below the actual cambium and then drops rapidly down, depending on, of course, the actual radius of the xylem. Same in a ring porous tree, the maximum sap flow is found just below the actual cambium. So in these graphs here, we've got an Acer campestre, and let's say we've got a radius of 160 mil, probably about 70 to 80% of the actual moisture uptake is within 40-50 mil of the actual radius of functional xylem. Fraxinus excelsior, what we've got with ring porous tree, of course, is that all of the sap flow is within 40 mil, or 4 centimetres, and most of it is within 2 centimetres. So we have to take this into account. We actually calculate and measure the actual sap flow with any reasonable accuracy. Now we have to take into account vapor pressure deficit, and students can look it up, VPD. If you don't already know what VPD is, I won't go into it now, but if you've got a high VPD, that is like a high temperature with a low humidity, so you've got quite a low water potential in the atmosphere, and that's drawing up sapwood quite rapidly through the tree. So you've got a high VPD, you've also got high sap flow. You've got a low VPD, so it might be a cold, wet, rainy day. You've actually got a low sap flow because you've got a much higher water potential in the atmosphere. So if you're taking a measure of sap flow and you're getting a low result, it's probably more likely to be due to a low vapor pressure deficit than anything else. So here we've got a Salix caprea, DBH 48 centimetres, height 7.7. on a VPD of 1.5 kilopascals, which is pretty much average for northwest of England. We've actually got Sapflow of 11.1 litres per hour. So this is an hourly snapshot survey in the middle of the day, and that's what we're actually getting, 11.1 litres per hour. So that sounds pretty good. So then we went over to Keithley, and this is a very specific exercise. We have an Acer campestre streetwise, have a number of them, planted about 40 metres in length on what's called a SUDS scheme, so sustainable urban drainage. And that's taking the stormwater runoff from the road, allowing the water to filter into the tree pits and then down into the permeable substrata, completely independent of any other mains drainage system. And it's proved to be highly successful, brilliant scheme, so that even in heavy storm you don't get any puddling or flooding or anything like that. And then somebody said, well, surely all that pollution going into the actual tree pit is not going to help the trees. So we went across there and we actually did some testing and got some real-time data. And note we had a very low VPD of 0.5 kilopascals, which is probably quite normal in Yorkshire, and an actual Sapflow of 1.3 litres per hour. So, okay, I thought that sounds pretty reasonable. Then I thought, well, how do I know? How do we know if this is a good result or not? Okay, so what context, what benchmark can I actually find that we can actually test this against? So I played around with some figures and eventually came across with this. This is fairly straightforward. We've got Sapflow measure of centimetres cubed per hour divided by actual live functional annulus of the Sapflow in centimetres squared divided by the vapour pressure deficit. And what I found was quite incredible was a score between 1 and 10. 1 of course being very poor, very low vigour, and 10 being a very high, very good, very vigorous and healthy tree. So it's not a perfect calculation. I've been intending to work on some seasonal adjustments perhaps over the next year, but it provides us with something to work on, some form of context, some kind of benchmark to go by. So go back to our samples. TVA ratio on the actual Salix caprea was 5.8, so that's just above average, which is pretty good. But over in Yorkshire, the field maples, we had a TVA of 10.5. Those trees were doing brilliantly. So we were able to actually demonstrate, or actually provide real hard time data as to the physical vigour of those trees in that situation, which is absolutely brilliant. So if you've got, for example, a feature tree that's planted in a development or something like that, and you're not sure whether it's doing well or not, we can actually provide actual real-time data on how that tree is actually performing. And this is an incredible example. Now, this is an oak tree, and for all intents and purposes it looked as though it was dead. It had lost its leaf early in the season, it wasn't looking very healthy, and looked as though it wasn't going very far. So what we found was there actually was some Sapflow in it. We had 6.8 litres per hour. So bearing in mind the size of the tree and the actual weather conditions, the VPD is 1.2 kPa, so the TVA ratio was only 1.8, but it was something. It was demonstrating that tree was still functioning, even though it lost all its leaf. So we know that oaks are very resilient, very substantial trees, so I'm hoping that next year's hydrotrophic root growth, we might see that tree starting to redevelop and do better. So I'd like to say thank you very much to everybody for listening. And what my message is to agricultural students when you're going into arboriculture and so on is innovate. Do something different. Do something that nobody else does. Take what you've learned and pursue it further. Set up your unique selling point. That might not necessarily earn you much money, but what it does mean is that people will sit up and take notice. People will notice that you do something that nobody else does, and people will take notice of you. So thank you very much, everybody. Thank you to Marco and to Duncan for being able to take part in this Arbor Day. Do have a look at iros-uk.com, or give me an email if you'd like to have further information. Thank you very much.